Welcome to cloudonaut Plus, your source for exclusive videos and online events for AWS professionals. My name is Michael Wittig, and today we investigate the options to run container workloads on AWS using spot capacity. So why should you actually care about running something on spot? The answer is simple. It is significantly cheaper compared to the other option, which is the on-demand option. So on the spot market, you get savings. For example, if you run on Fargate, and the savings are around 70%, so 70% savings. So that is significant. And for example, if you run on EC2, depends heavily on instance types and also regions. But for example, I checked the M5 large in US East 1, and there you get a 57% savings compared to the on-demand option. So basically, without changing anything, you get significant savings. So what can you expect from this video? First, you get a short spot refresher. So what spot is, how it works, and what is important to know. Then we have a short demo about using spot on ECS Fargate. We will talk about a pitfall. The first one is how you can handle the interruption notice. So when your spot instance is terminated. The other pitfall we have a look at is what you can do to fall back in the case of there's no spot capacity available and fall back to on-demand. So what are your options there? And last but not least, I have a demo around EKS using managed node groups to kind of implement what we talked about before in the fallback behavior. And this is actually the topic that was asked for by the community. So it was specifically about the EKS use case. And what I did in this video, I expanded the question a little bit so that we look into all the available options. So this is where we talk about options, right? So when we run containers on AWS, we always have to choose between ECS and AKS. And that's a completely different topic. So ECS is AWS native container orchestration. AKS is Kubernetes-based container orchestration. Within ECS, we basically have two options. We can run the workloads on Fargate, or we can run them on self-managed EC2 instances. On the EKS part, we cannot use Fargate on the spot market. That's not possible. Fargate doesn't support that for EKS yet. It is a feature that is quite, I would say, asked for many people are asking for this feature. So I think that we will see support for that in the future, but at the moment it's not possible. So the option is not existing. That's why I striked it here on the slides. Then we have managed node groups. So that's something that doesn't exist on ECS. So it's actually something in between. So you don't care much about the EC2 instances here. So that's managed by AWS. And then we have the self-managed nodes. So this is basically you run your own EC2 instances and connect them to AKS. So those are the options when we talk about running containers on spot on AWS. But one thing you have to keep in mind, when I kind of started this video, I mentioned that spot is super cheap. But always keep in mind that if you pay less, you get less. And that is very true for spot instances and also spot containers, because spot workloads can be interrupted at any time. So if AWS runs out of capacity, basically if there are lots of people requesting on-demand capacity, they will move that capacity from the spot market and shift it to the on-demand market. So this basically within a couple of minutes, big chunks of capacity can be moved away from the spot market. And this means your workload is likely interrupted. If you are lucky, you are noticed 2 minutes upfront. So if you run an EC2 instance on the spot market, there are ways to get notified 2 minutes ahead of the time where AWS just shuts down the instance. But this is all kind of on a best effort basis. So this is nothing that you can rely on. So something else that I want to mention when we talk about spot and the spot market, because this is like kind of in the brains of many people. And the thing is that AWS changed something here, and it is actually a change from December 2017. So that's quite an old change. But when I talk to people, I noticed that many kind of have not really noticed that change. And it's a very significant change. The spot market is not a market anymore. So before that change, your bid influenced the price of the spot market. As you can see in the graph, at the very beginning of the graph, maybe the first, I don't know, 10% of the graph, you see the price is very volatile. And then AWS made a change to the market, and all of a sudden your bid does not influence the price anymore. The price is only influenced by the capacity that AWS has available, and the price moves very, very, very slowly, as you can see. So there are no spikes anymore in the price. This is good for us because it makes running workloads on spot much more predictable. It's more stable. But this is something you have to keep in mind. It is actually easier to run stuff on the spot market and now that it's not a market anymore because the price is very constant, I would say. So this is something to keep in mind before we start with the first demo. So first, workloads can be interrupted at any time. So this is very different from what we know. Like if you compare this to the availability of on-demand, this is really different. That's why it's cheaper. And then keep in mind that the spot price market is not really the market that it was anymore. So you cannot expect this huge price volatilities during the day. It doesn't exist anymore, basically. It's very, very stable. All right. So time for the first demo. I picked ECS Fargate because that's, I think, the best option to run a container on AWS, and it also supports the spot deployment option. So that's why I picked Fargate first, and then we move on to the EKS option. So what I want to share with you here is I made a change to our open source templates to support Spot Fargate. And I basically want to show you what I needed to change to support it. And then we will look at it like an application running on Spot Fargate. Because the thing is, with Fargate, there's not a lot that we see actually. There's only like basically one string that is different compared to running on-demand capacity. So it's very simple in terms of the kind of what we can observe. So everything is taken care of by AWS. So that's pretty nice. So let me share you what I did in my CloudFormation template. So, okay, I introduced the parameter. I mean, that's not really important. So this is basically to allow me to flip between spot and on-demand. But the interesting part is this. So within the ECS service, I added an attribute called capacity provider strategy. And when I add this attribute, you must be sure that you remove the launch type, because there can be only one of those two attributes. So first I forgot to remove the launch type, so then I was running in an error, so that's why I mentioned it here. So remove the launch type and replace it with the capacity provider strategy. And you can have multiple capacity providers. So for example, you could mix spot and on-demand capacity providers. We will talk about that later. But in this case, I want to run 100% on spot. So what I say is that the capacity provider is set to Fargate underscore spot when I want to run on spot, and otherwise it's only Fargate. And those are strings defined by AWS. So each cluster has a Fargate spot and a Fargate capacity provider. There are also options to create your own capacity providers if you like, and that's not necessary in this case. So it's really just this string, and this is kind of a magic constant that AWS provides. So that's the only thing we need to do. So there are two other attributes. I set base to 0. You can leave that. Basically, can just remove it because base set to 0 is the default. It has no impact in our case where we have only one capacity provider. If you have multiple capacity providers, you can say, okay, for these capacity providers, first scale, like the first N containers run on these capacity providers, and then the others are distributed based on the weight that you can assign. So in our case, that all doesn't make any sense because we have only a single capacity provider. But if you want to use more than one, you can have different weights. So for example, you can say, I launch every third on spot and 2/3 on the on-demand market, or the other way around, for example. So that's it. That's the only change you have to do. So remove the launch type and replace it with a capacity provider strategy attribute. That's it. Deploy it and it runs on spot. So question is, how does it look like? So how can we know that it really runs on the spot market? So I will quickly look into the ECS console. Okay, ECS Elastic Container Service. So that's where I schedule this workload. And I have an ECS service running. So it is based on the template that I showed you. So it really is nothing special. And if you click on the task, there's only one task running here. So that's not a production ready thing. It just runs a single container. And as you can see here, the capacity provider is set to Fargate_spot. That's the only thing you will notice, besides maybe a drop in your AWS bill when you look in the ECS category. So that's all we need to do. It's very simple, I think. It's a very small change. It has a big impact. And that's the easiest way to run something on spot capacity on AWS. But that's not all, right? I mean, there are other options, I promised. So a couple of pitfalls I want to mention first. If you plan to self-manage your EC2 instances, basically the container instances, then you have to make sure that, or I would strongly recommend to ensure that the spot instance interruption leads to a draining of your ECS instance. So draining basically means that the running containers are moved away from that instance and are rescheduled on other hosts. So this is the only way to try to achieve a not user impact, like to ensure that there is no user impact. So move the containers away before they are killed by like the machine is shutting down. So there are two ways to get this event, the spot instance interruption event. First is using CloudWatch Events or EventBridge. You can just subscribe to the EC2 spot instance interruption warning. It contains the instance ID. That's basically all you need to know. And then you could connect the Lambda function to that, and you make the API call to the ECS API to set the instance to draining. That's all you need to do. And I think that is the easier way. The a little bit more complicated way is to run something on the instance itself, the EC2 instance, and constantly check the metadata service and ask for this instance action. And if the instance is scheduled for termination, you will see that in the response, like this is like a JSON response that you get back. And then you can act accordingly and basically call the ECS API. The problem with this approach is then your instance itself needs permissions to drain itself, which I mean, it's not optimal. So I would do that in the Lambda function. So then your instance doesn't need that permissions. So keep in mind that this is something that you have to do. You have to implement that. Otherwise, you will have user impact because the machines will just be terminated and in-flight requests will kind of die because there was no kind of graceful shutdown implemented. So the other kind of concept that you have to understand is that your spot capacity can kind of go away at any time. So the kind of natural way to solve that is this. Why not fall back to on-demand in case of a spot shortage? The problem here is that it's not so easy. So with Fargate, you can only define waits. So if you have two capacity providers, you can only say, okay, half of my capacity runs on on-demand, the other half on spot. But if spot goes down, AWS will not reschedule all the capacity on spot and move them to on-demand. They will always keep this 50-50 balance, for example, if you set the weights in an even way. So this is not an automatic fallback. There is no way to implement an automatic fallback, to be honest. The same applies to self-managed EC2 instances. So if you run them in an autoscaling group, you can do all kinds of things to reduce the risk of being terminated because of a capacity shortage. So for example, you can spread across multiple instance types. You can spread across multiple availability zones, which you should do anyways. But still, there is no way to tell the autoscaling group that it should launch on-demand capacity if it cannot get the spot capacity. That feature does not exist. And I think that AWS does not add this feature on purpose. Because otherwise, always when like the spot market is completely empty, all the customers would immediately spin up on-demand capacity, and that will create large problems on their infrastructure. So that's why I think this feature is not available, because many people ask for that. And for example, for the autoscaling group, we asked for that feature for many years, and it's still not available. So I think there is a reason for that. So don't expect this to be solved by AWS soon. So there are a couple of I would say workarounds. So for example, in the EC2 case, you could monitor your autoscaling group, and if the capacity drops quickly, you could kind of indicate or you could kind of conclude that there was a spot market problem. So you could just readjust the weights, for example, like with a lambda function or something. But this is all, it's very tricky to test because you cannot really simulate a shortage in the spot market. So I don't recommend it. So if you run a workload on spot, you have to accept that it can go away at any time. The only exception where this is all managed for us is within the AKS or the Kubernetes world. So with AKS, you can use 2 node groups, one for spot and one for on-demand. And then you configure the Kubernetes autoscaler with priorities. And the priorities favor the spot node group. But the autoscaler is smart enough that if he cannot launch instances, it will fall back to the next priority and basically then spin up on-demand capacity. So that's very smart, and that's basically what lots of people are looking for, and it's implemented only by the Kubernetes people, not by the AWS itself. So the autoscaler is not really like something that AWS developed, it is something that comes with Kubernetes. So we can use that feature, and then it will work. So there's one configuration option to keep in mind, and that's the max node provision time. It defaults to 15 minutes. So the autoscaler waits for up to 50 minutes to, like, if the instance doesn't launch within 50 minutes, the autoscaler will think, okay, that's not going to work anymore. And then it will fall back to the other, like the lower priority node group. So you likely want to adjust that limit a little bit and maybe reduce it to 5 minutes or something. But that's a good option. So I have a demo for you that basically uses exactly the approach that I talked about before. So we have 2 node groups, the spot and the on-demand one, and it falls back to on-demand if there's no spot capacity available. So let me switch into my terminal and then we see how it works. Before we start, I prepared a couple of things. So I created an AKS cluster and I installed a couple of things. You will find the details in the video description in our community. So this is just taking a little bit too long for a single demo here. So that's why I prepared it. So what I'm going to show you is, let me start by showing you the running pods in this cluster. Okay, there's a single pod running at the moment, as you can see. So that's nice, and I can also show you the running nodes. Okay, so those are the running nodes. A single node is running, so I moved this up a little bit. So that is good as well. So now I would like to understand if this is a spot or an on-demand node, because that's actually what we are interested in, right? So I can do this by asking again the Kubernetes cluster. I describe the node and then I have to copy the host name. And there's actually quite a lot of output. So that's why I do some crapping and I crap for node group so that I only get the output that I'm interested in. So as you can see, the node group, I moved this up a little bit. So the node group is set to spot NG, so spot and NG for node group. So this node is a spot node and it runs our pod that is running at the moment. All right, so let me scale up to 2 pods. And we will see that now there are, no, not yet. No, that's not the wrong command, sorry, get pods command. All right, as you can see, there are now 2 pods kind of visible and one is pending. This means the cluster is now trying to kind of schedule this pod. The cluster has no capacity left because I configured the pods in a way that they kind of consume a whole instance, a whole node. So basically every pod that I add forces the cluster to scale up. So this is just for demo purposes. So we have to wait a little bit here until this pod is running, and then we can continue. All right, the second pod is now running, as you can see in the list. So that is expected, and I will get the list of nodes now once again, and now we will see 2 nodes, and that's again also expected. So let me look at the details of the second node here. So, and I will copy the name of the one that was launched a couple of seconds ago. So that's the one. Oh, I forgot the crap. All right. Move that up. And as you can see, this node group is also the Spot and G node group. So this also runs on Spot. So that's exactly what we expected because the Spot node group has priority. So what I'm going to do now, before I scale up to 3, I limit the auto-scaling group, which powers the node group, to a maximum of 2 instances. This basically says you cannot launch any instances anymore. This is a very kind of poor man's way to simulate a spot market shortage. There is no way to simulate that, so that's why I kind of use this workaround. So this basically sets the upper limit to 2 on the auto-scaling group, while Kubernetes thinks it's actually 10. So there will be some problems when Kubernetes launches or tries to launch another node, or the autoscaler tries to launch another node. All right, so this is now set to 2, and I run the scale command again, but this time I scale to 3 instances. So that's done. And now we have again to wait. So if I get the list of pods, I will already see 3 of them, but 1 of them again is impending. So again, we need a little bit of time. So let's wait for that until a new node is created. So the 3rd pod is now running as well. So Kubernetes was able to start it. Let's look at the node. Sorry, I have to type and talk. That's not so easy. So now we have 3 nodes running. So that's also kind of expected. And I describe the new node. So let me pick the right one. So that's the one that is youngest. Okay, and I grab the output to only get what I'm looking for. So now we see something different. The node group name is now set to on-demand instead of Spot. So this 3rd pod was not launched on a Spot instance. It's now launched on the on-demand capacity pool, which runs on on-demand EC2 instances. So that's great. That's exactly what we need. So if we don't have Spot capacity, we will use on-demand capacity. And if the Spot capacity kind of goes away during the day, we kind of replace all the pods with on-demand pods. So that's pretty cool. And only Kubernetes has built-in support for that, which is nice as well. So that's, I think, one argument for using Kubernetes. You can reach out to us and the community about this topic or any other AWS related topic at any time. To do so, visit community.cloudonaut.io and ask your question. We are happy to answer your questions, and I'm certain that parts of the community are also very interested in reading about your question and may also join in the discussion. So thanks for watching. Don't forget to like this video if you learned something new today. Your feedback helps us to create relevant videos. You can reach out to us via email, via Twitter, or directly on the community with your topic suggestions. So we will see each other in 1 week. Thanks for your support. Bye.